Now let us try to solve this problem. In this problem there is a three for loop. Okay, and initialization of I j is there is only one variable, that is I. Okay, now let us try to solve. Okay, when I equal to 1, the loop will enter in this for loop. No problem, I is less than n, so enter in the second for loop. There is also no problem, so enter in this third for loop. This for loop is starting from I equal to 1 and go till n cube. Okay, so I value will be first time 1. The same I value is again initialized in this for loop 1, and the same I value when enter in the for third for loop, again it will initialize 1. I value initialization is 3 times. Okay, now I value will enter in this for loop. First time I value, now this statement will be execute for first time. Next I value will be I plus 1, that is 2. Next time this statement will execute 3 times. Dot dot dot. This statement will be executed for n cube time. Okay. Now when the value is greater than n cube, I value will be greater than n cube or almost equal to n cube, then the loop, this loop will be terminate. Okay, now when this loop will be terminate, it will return in second for loop. Here value of I equal to I is value of I is greater than n cube. Okay, or almost equal to n. This when I value become n cube or n cube, then this third loop will be terminated. Okay, and when this third loop will be terminated, then it return to second loop. So here n I value will be n cube, because in all the for loop we are using I same variable, that is I value is lesser, I value is greater than n square, then second loop will also terminate and it return to first loop. Here n cube lesser than equal to n, this is wrong, so first loop will be also terminated. And this is the problem is occur due to we use same type of variable in all the three for loop. So overall, what will be the time complexity of this algorithm? That is n cube. Now how many time first loop will be executed? Only one time. When first time I equal to I initialize 1, then it will enter into second for loop, and again I will initialize to 1, and in third loop again I value initialize equal 1, and here in third loop it will execute for n cube time. Now I value become n cube, then when third loop will be terminated, then I value equal to n cube, and n cube is less is greater than n square, so first loop will second loop will be terminated there, and also n cube is greater than n, so first loop executed for one time, second for one time, and third loop will execute it for n cube time. Okay. So what will be the time complexity of this entire algorithm will be order of n cube, and the problem that first and second loop executed only one time is due to we use same type of variable in all the three loop. Okay. Now let us try to solve this problem. In this problem, I is initialized here 1, then I from 1 to n. Okay, no problem. In second for loop, I is initialized again from 1 and go till n to power 4, and in third loop it is again initialized 1 and go till n cube. Now consider this, and we will try to solve this problem. This loop will execute from 1, then 2, then 3. First I value, let's take I value. I value will be first time for in first loop 1, then I value will be n, again in second loop I value will be again reinitialized to 1. In third loop it is again initialized to 1. Okay. Now in third loop it will initialize 1, then 2. Here it will execute for 2, 3 dot dot till n cube time. When the value of I become n cube, then the third loop will be terminated and return to first loop, second loop. Here I value is n cube, which is lesser than n to the power 4. Here I value will be n cube. Okay, no problem. It is lesser than n to the power 4. Then again it will insert in third loop. There I value will be reinitialized to 1. Then again 2, 3, 4, 5 dot 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 n cube. Okay. Now I value will be now n cube. Again it will return, terminate, and I value become again n cube. Every time when third loop is will terminate, I value will be n cube, and n cube is lesser than n to the power 4. So again and again when third loop is terminate, it will go to second loop. Here second loop will less than n to the power 4, so it will again enter in third loop. This will keep on going again and again, that third loop will execute for n cube time and it will terminate and go to second loop. Their second loop will is less than n cube, so it will enter again in third loop. So this will never terminate, and this is not an algorithm actually, because if loop is not terminating, that it is going to infinite loop, because here in third loop it will come and make n cube, and again it will return to second loop, then it is less than n cube, and again and again I value will be initialized and go to till n cube, and then again it will return. This will keep going, and this is not an actually algorithm, this is a program, and we read in previous video, or in actually in first video, that is first or second video, that it is not necessary that every program is an algorithm. Algorithm in first or second video we discussed that algorithms should terminate after finite time or finite step. Actually their step is finite, so it should terminate after finite time and should produce at least one output here. It should terminate after finite step. Step is finite, but it is not terminating. So it is not following algorithm properties, and so we can say that it is not an algorithm. And there are some more algorithm properties, that is it should produce at least one output. Yes, it is producing some output, and take 0 or more input. Yes, it is taking some input, that I equal to 1, every time it is taking some value. It should be deterministic. Yeah, actually we can't say anything because here x y z is not defined, so saying anything about deterministic is not possible here. And one more property is that is it should be independent of programming language. The same code we can write in any programming language, but the first property is that is important. It should terminate after finite time or finite step. It is not following this, so we don't need to think too much. Directly we can say that this is not an algorithm. This is the approximate every type of algorithm, finding time complexity of algorithm we discuss in previous video. Our next topic is asymptotic notation, and this is the maybe last type, or if you have any another type of algorithm and you want to solve and you want to get that answer, you can write on comment box or send me in my mail. Our next topic will be asymptotic notation. Thank you. If you have any comment confusion, you can write on comment box.